Hi everybody, this is Kai Wehner from CONFLUENT. Today I will talk about architecture patterns for distributed, hybrid, edge and global Apache Kafka deployments. As you can already see in the title, there's a lot of things to discuss, and I will show you many different architectures I've seen in the real world and deployments at many of our customers. So let's get started. Here's the agenda for this session. First, I will define what I mean with a Kafka cluster, and then I will tell you when one Kafka cluster is good enough and how you can set up one Kafka cluster. But then the main part really is about deploying multiple Kafka clusters for many different reasons. And then we even go one step further to discuss multi-region and even global Kafka deployments. At the end, I will talk a little bit about the infrastructure options, because obviously depending on what kind of architecture you choose, you will have to make decisions about cloud, on-premise, bare metal VM, and all these kind of things. So let's get started with the definition of an Apache Kafka cluster. I will not really introduce Kafka in this talk. There is a lot of material on the web where you can learn more about Apache Kafka, but this is really the main focus of this talk here. So just really quickly, I go through the slides that I explain Kafka was built at LinkedIn and open sourced and Apache Foundation, and they built it as first use case for log analytics, processing big data sets in real time and connecting many different systems. This is why Kafka was created. But today it's much more. And under the hood, Kafka is an event commit log. It's a highly available distributed system where you can process and send data in real time, but it's also a storage system here. So this is the log where producers send data and consumers consume the data. All are decoupled from each other. And under the hood, it's a distributed system. This makes it highly available, and it works even in case of failure of hardware nodes or network problems or disk crashes and so on. That's the main idea why Kafka works so well and is adopted for more and more use cases. It allows real-time processing, large scale, high availability, and decoupling of the different producers and consumers. Under the hood, it uses partitions, topics, replications, and many other concepts which I will not cover in this talk. So I assume you know a little bit about Kafka and why you use it. And here you want to learn today about the different architectures and deployment options. So just one more thing, Kafka includes Kafka Connect and Kafka Streams. That's what many people are not aware of, but you have to understand this when you plan your architecture, especially with multiple clusters and over different infrastructures. With Kafka Connect, you can integrate to any kind of source or sink systems, no matter of legacy systems like mainframes or MQ interfaces, or new technologies like Hadoop, Flink, whatever you want to integrate with. And Kafka Streams can be used to continue stream processing natively with Kafka, without any other additional framework or infrastructure. So this is really important to understand. Kafka is not just the messaging and storage layer in the middle. That's the core. But besides that, you also have Kafka Connect for integration and Kafka Streams for stream processing. Therefore, here is what you see what Kafka is. It's really the underpinning of an event-driven architecture. The key difference to other tools like messaging or ETL tools is that the core foundation is event-based. So everything is stored as events in the distributed commit log. And that's really huge, because this way you can consume the data in real time, and others can consume it in near real time or batch, or you can get the data via request response. But the point is the core foundation is real-time and event-based, and this is really the future for many new applications and therefore the foundation for many projects. And the other big thing here is that it decouples the producers and consumers from each other. And that's a very significant difference to any other messaging system like RabbitMQ or IBMQ or any kind of ESB or ETL tool on top of that. Kafka was adopted by many tech giants, so here's just a few examples. So LinkedIn in 2019 announced that they now process over 7 trillion messages per day, and Netflix processes over 6 petabytes of data per day. Any kind of tech company uses Apache Kafka in the meantime for many different projects. Having said this, Kafka is not just used by the tech giants. We will see a few examples in a minute. So it's really used everywhere in the meantime. And maybe even more important, Kafka is not just used for big data. 70 or 80% of projects I see are about small or medium-sized data sets. It's more about criticality, mission-critical systems, real-time processing, decoupling producers from consumers, building microservices. That's why people use Kafka, not just because it supports big data sets. And therefore, here are a few examples of what we can do with Kafka. The main point here is to show you that Kafka can be used for many different use cases. And so I shared a slide so you can take a look at all the references. Or you simply go to the Kafka Summit websites where hundreds of companies explained how they use Kafka in almost any industry on this planet. So now we come to the question, what is a Kafka cluster? And here you see one. So a Kafka cluster means that you have at least a Zookeeper and brokers. So this means this is the core foundation. Zookeeper is the distributed key value store and for managing the checks to the check alive and the availability of all the systems. And the Kafka brokers, which process the data and do the storage between the producers and consumers. And then you also have additional optional components. In most deployments today, some of them are used, like a schema registry for enforcement of the message structure, or a Kafka Connect, as we heard before, for integration to different systems. So this is actually what I mean with a Kafka cluster on a very high level. And therefore, the Kafka cluster has a server side and a client side. So you have to get at least one Kafka broker and one Zookeeper, and all the other ones are optional. And of course, what I will not really cover in this talk here is that you always have to cover security, operations, and monitoring. On the client side, you can either have just producers and consumers in different programming languages, or maybe just a REST interface with the REST proxy. And you have stream processing apps. This can be native Kafka apps, which use Kafka streams or KSQLDB for continuous stream processing. And then obviously you have many external producers and consumers, and this can be anything, no matter if it's a database, a big data system, or another stream processing engine like Flink, Spark Streaming, or Storm. The point here really to understand that with Kafka you always have to think about the whole infrastructure, not just the server side, because the real power is in the clients. That's where you implement the business logic. And this also leverages Kafka under the hood with high availability, high scalability, and high throughput. So it's always important to think about the overall system. So why do you need more than one Kafka cluster? Right? Here's a survey Gwen Shapiro did in 2017, and of course it's not representative, but it's very interesting and it more or less shares why people build multiple Kafka clusters or Kafka clusters using many data centers. So number one is often disaster recovery. If a data center is not available anymore, you still want to get zero downtime and often even zero data loss. Often it's simply because it's remote regions. So someone is in USA, someone in Europe, and there's a lot of latency and other issues between the continents. Sometimes it's more for legal reasons like compliance and regulatory reasons. And there is many other reasons. So sometimes you want to deploy it in multiple data centers because some applications run in the cloud and some others run on premise, for example. All right, so there's many use cases why you build multiple Kafka clusters and why you use many data centers for one single Kafka cluster. The main point here really is that we see more and more mission-critical deployments of Kafka. This means you always have to care about RPO and RTO. So this is the most fundamental concepts you have to understand about high availability and mission-critical systems. RTO means recovery time objective. So here from left to right you see the time going on, and at one point there will be an outage. And then the RTO, the recovery time objective, defines how long it takes until you are ready for running the system again. So what is your outage time is the RTO, right? After the damage happened, how long does it take? Does it take an hour, a day, or maybe you have zero downtime and continuously process data? RPO, the recovery point objective, on the other side looks at how much data can you lose. So this means when you have an outage, how much data back to the past will you lose? And when you get started, you have lost some data. Ideally, of course, you have zero downtime and zero data loss. And I will cover options where you can realize this with a Kafka infrastructure. However, it always has trade-offs, and therefore we will also discuss other options. It's always a trade-off between RPO and RTO and cost, and therefore you have to define your SLAs to choose the right architecture. So with that, let's now take a more deeper look into one Kafka cluster. Here again, this is our Kafka cluster. It has Zookeeper instances, Kafka brokers, and other optional components. The important thing is really Zookeeper and Kafka are mandatory, and typically they are highly available. Therefore, you see here in a production system or pre-prod, or even in a reasonable test system, you should have at least 3 Kafka brokers for high availability. It doesn't make sense if you don't test it in a real-world infrastructure, because a distributed system has to be tested in the same way like you deploy it for production later. You have to have 3, 5, or 7 Zookeepers, depending on your SLAs, but it has to be an odd number because of the quorum for Zookeeper and its distributed algorithms under the hood. For most other components, you have at least 2 for high availability, so that even in case of downtime of a node, you will not have downtime of the infrastructure. So most of these are deployed at least a number of 2, often even more, like Kafka Connect or REST proxy or any other client can scale up, so you can also run 10 instances and parallelize the processing. On the other side, as you see on the right side, for just development and functional testing, 1 Kafka broker and 1 Zookeeper, and 1 optional number of the additional components is fine, right? But in most reasonable deployments, you should have the left side with at least 3 brokers and 3 Zookeepers, and everything else twice for high availability. Now we already come to a very interesting point. We talk about a stretched Kafka cluster over 3 data centers. This is actually one of the best deployments you could do, because this setup guarantees high availability without data loss and without downtime. This means even if a data center is completely down, you have 0 data loss and 0 downtime. This works because still 2 Kafka brokers and 2 Zookeepers are available in other data centers. So this is the go-to option for 0 data loss and 0 downtime. So this sounds really great, does it? Yes. I just explained this has a lot of advantages, including things like also automatic client failover. This means even if a data center is down, you don't have to reconfigure the clients because they already know the brokers and Zookeepers in the other data center. And actually the good news is in cloud, in public cloud, this works very well because there you have very good latency between the different availability zones in a region. So deploying a stretched cluster over 3 assets in one region is very straightforward to do with any public cloud provider like Google, Amazon, Azure, or Alibaba Cloud. However, and now we come to the big drawback, and that's the reason why many people cannot deploy a stretched cluster, and we actually do not recommend to deploy a stretched cluster on premise in many cases. It requires very good latency, and this means that typically the DCs have to be close to each other. We say that typically the end-to-end latency between the data centers should be less than 30 milliseconds. And even more important, it has to be a stable connection without connection spikes, because that's what creates trouble. And therefore, the other big point is, of course, it requires 3 data centers for the quorum and split brain components or concepts of Zookeeper. Therefore, 2 data centers is not that good. You need 3 of them. And actually on-premise, most traditional companies often have only 2 data centers. One workaround, what we see as a 2.5 data center deployment, is that they use a 3rd data center just for a Zookeeper. This can be either a small part of one of the 2 data centers, which have their own fire zone and alarm zone, so that it's its own uptime SLAs. Or this can be a separated data center, which is not that powerful, but still close, so that you have good latency. And also, while all this looks very good on the slide, this is really hard to operate. We have several customers doing this in mission-critical deployments to guarantee 0 data loss and 0 downtime. It works totally fine, but you know how to configure and operate it well. So I would never recommend to do this without getting help from the experts like CONFLUENT. It's really, especially when it fails, it's hard to operate when the DC is down. So that's where we need to give you the help to configure it the right way. But it's definitely doable if you have 3 data centers with good latency to each other. So the other point is, of course, now many people only have 2 data centers. So this is still possible. In this case, you have 2 different deployment options. Here you see the regular stretch cluster. You have 4 Kafka brokers in this case. It's important to have the same number of brokers in each data center. And you have 3 zookeepers. So here you already see the problem. So if DC1 is down, well, then you don't have uptime anymore because there's no quorum for Zookeeper. So it's not good if DC1 is down. DC2 could fail on the other side. Another deployment option is to have a hierarchical quorum where you deploy more Zookeepers. So this means one Zookeeper cluster in each data center and making a quorum between the 2 Zookeepers. However, having said that, this is possible, but this is really a workaround if you don't have 3 data centers. So there is some pain with that. You can only guarantee 0 data loss or 0 downtime, not both together, because for that you need 3 data centers. And therefore it's often a stopgap solution for on-premise if you only have 2 DCs. Right? So the big point here is you still need good latency between the data centers, and you cannot create a quorum with 2 data centers. So you have to decide between 0 downtime and 0 data loss. And with that, depending on like the deployment in this picture, you can do 2 Zookeeper and 1 Zookeeper, or 3 Zookeeper and 2 Zookeeper, which is 5 in total. This is one option. Or the other option with the hierarchical quorum. And the trade-offs are really uptime versus data loss and what is more important for you. Right? But it's not possible to do both. However, we have seen many cases where some downtime is acceptable, but the customers want 0 data loss. And that's exactly what you can do with this infrastructure and configuration. Another option for one single Kafka cluster is that you use it with 1 broker. This sounds a little bit strange in the beginning, and I often say that Kafka is a distributed system for high availability. And that's totally true. However, there's no reason not just to use 1 Zookeeper and 1 Kafka broker, if you can live with the big drawback that you will not have high availability. But for many use cases, especially often used at the edge, whatever the edge means like a retail store or a factory, you can deploy it without high availability, but still leverage all the other features of Kafka. Decoupling the producers and consumers, storing the data for reprocessing, and messaging at scale in real time. So this is still all doable also with 1 broker and 1 Zookeeper. And if you don't need HA, this is totally fine, and we see more and more people deploy it, sometimes on special hardware or as OEM product. So there's many reasons why you should deploy Kafka at the edge with 1 broker instead of 3. It makes operations much simpler because it's not a distributed system anymore, and the drawback is no HA. With this now, we talked about 1 Kafka cluster. So now let's think about multiple Kafka clusters. There are many different architectures and use cases for this. The first one is the independent Kafka clusters. Obviously, if you have completely separated business units and teams, they can deploy their own Kafka cluster, maybe also in different data centers or clouds. And then you don't care about the others. You just do your thing and configure and run it the way you want to do that. So this is totally fine. So totally independent clusters. Sometimes they are even operated by 1 central ops team, or sometimes use a SaaS service like CONFLUENT Cloud, where you get consumption-based pricing and elastic scalability. You really just pay as you go in a serverless way on the different major cloud providers. Having said this, you also can, of course, do 1 Kafka cluster for different teams and units. Actually, related projects should often run on the same Kafka cluster, because one of the great things of Kafka is that different consumers are decoupled from each other, and they consume the data when they want, how fast they want, and how often they want. And therefore, that's really huge, and therefore, 1 Kafka topic could or should be consumed by different consumers. So if you build different projects around 1 business case or 1 business department, it totally makes sense to run them in 1 Kafka cluster. And even for independent projects or completely separate business units, it totally makes sense. You just have to think about how do you solve things like SLAs and other requirements so that you have similar configuration requirements for that. So an example is don't do instant payment and batch log analytics with 1 Kafka cluster where you have terabytes of throughputs of logs, and on the other side want to do instant payments in milliseconds with completely different SLAs regarding uptime and data loss. For these things, then it makes sense to have 2 different Kafka clusters. But if you have one Kafka cluster, you have the access control list of Kafka. And then also with tools like CONFLUENT platform, role-based access control for fine-grained authentication and authorization. And also you can configure things like quotas. So there is no problem to deploy different projects and people on one Kafka cluster. Also, don't worry about throughput too much. If you don't really have a big scale use case, it's no problem at all. At CONFLUENT Cloud, we have customers which process 1 GB per second and more in one single Kafka cluster. This is not a problem at all if you can deploy it the right way with the best practices. And on the other side, the big advantage is reduced overhead, because you only have to buy one hardware, one operations team which operates one Kafka cluster, even if it's used by different teams which are separated in a multi-tenant way with quotas, RBAC, and so on. However then, in addition to independent Kafka clusters, sometimes you want to integrate different Kafka clusters. Here you see two independent Kafka clusters which are integrated with each other. DC1 and DC2, and these could be on-premise, this could be cloud, this could be edge, no matter where they run, or multi-cloud maybe, AWS and Google. So here you see in the middle, there is many different streaming replication tools. These tools do one thing: they replicate data in real time from one Kafka cluster to the other. This can be, depending on the tool, just unidirectional or even bidirectional communication in both directions. All the different tools have different trade-offs and pros and cons. You have to evaluate them. But my big point here is really, if you want to do something serious with mission-critical deployments, you probably would go either with MirrorMaker 2 or with CONFLUENT Replicator. The reason for that is that MirrorMaker 2 is part of the Apache Kafka project, and CONFLUENT Replicator on the other side is used by CONFLUENT for many years, battle tested in mission-critical deployments. So that's the main reason why I recommend these. All the other frameworks you see here, or you build your own custom integration, work also very well, but it's not really maintained by a vendor, and you don't know what's going on. Is it supporting the most recent version? Who fixes bugs and security issues, and all these discussions. And having that, never use MirrorMaker 1. It doesn't work well, it has too many issues. Both MirrorMaker 2 and CONFLUENT Replicator are based on Apache Kafka and Kafka Connect, and they are the right way to go if you want to have a real product which is developed continuously and supported by vendors. So there are many use cases here, as I said: on-prem, cloud, edge, unidirectional, bidirectional. However, again, on the picture it's simple. Under the hood there's a lot of things you have to consider. So what's your SLAs and timelines? What's the best practices? How battle tested is the tool? So while I do the recording here in January 2020, MirrorMaker 2 is just out for a month. So this is very new and not used in production and battle tested. So today I really would recommend CONFLUENT Replicator for anything serious. If we talk about this in a year, then probably MirrorMaker 2 is another very good option, because then it's used in different projects at production level. And by the way, CONFLUENT supports both Replicator or MirrorMaker 2, so we can also help you make the right decision. The good news about these tools is they work, they are proven, and they are relatively easy to set up, depending on which tool you use. Again, regarding maturity, documentation, if they're up to date, and all these kind of things. So there's many reasons why you want to do streaming replication between different Kafka clusters. Another use case is the migration of Kafka clusters. We see many customers which deployed Kafka on-premise or in their self-managed infrastructure in a cloud provider and want to go to a fully managed service or to another cloud. And in this way, you want to do a migration. A migration can be a one-step thing, or it can be a continuous migration which runs over long term until all the backend application in the old Kafka cluster are turned down or replaced. So these are the options where we replicate into one direction. As I said, often it's from a self-managed Kafka cluster to a fully managed Kafka cluster. There's many different use cases here, as you see. Also, sometimes we replicate data from a different vendor. So more and more use cases are seen where people started with a data lake with all the different frameworks, Hadoop and Spark and Hive and Kafka as data ingestion layer, and many more. And then when they really get to this case where they want to deploy a mission-critical Kafka cluster, they move away from the data lake architecture for Kafka, because that's not a good fit for Kafka. It's Kafka for a mission-critical system has to be a separated infrastructure with its own tooling and monitoring to really run it 24/7 with zero data loss and zero downtime. That's not what it was built for in the data lake use case. And therefore, this is one of the common scenarios where we replicate data from the Hadoop Kafka cluster to a mission-critical separated Kafka cluster. The migration steps are pretty straightforward. It depends a little bit on how long you want to run the existing Kafka cluster in parallel. There's a lot of best practices, and this is really our daily business, what we do with customers. So we can help you here with SLAs and timelines and how to configure this the right way for your requirements. Now, one of the most important use cases for multiple Kafka clusters, disaster recovery. This means you want to be sure even if a data center is down, and this happens. I've seen several customers in 2019 where one data center was down due to different reasons. And then you want to be able to continue your business 24/7. Remember the discussion about RPO and RTO. In many cases, you want to have zero downtime and zero data loss. So this means that if DC1 is down, the consumers consume from DC2 without any downtime. The good thing here is if Kafka Cluster 1 is down, Kafka Cluster 2 is still alive and running and has synchronized the data in real time from data center 1. However, again, on the picture it's easy. In the real world it's a little bit harder. It's different distributed systems, so you have to think about Kafka-specific things like timestamp preservation or offset translation. And also especially hard is the manual client failover and the custom client code. You have to write this. And you don't have just to write this, but also to test this in a mission-critical way. It's really hard to do. CONFLUENT has some tooling to provide this solution. So we have customers, and not just a few, but really many, which deploy Kafka for disaster recovery like this, as you see in this picture today. And this works very well. However, the big drawback, and that's what many people are not aware of, is that this architecture will have data loss in case of a data center outage. The reason here is that all these replication tools you see here use asynchronous replication from one data center to the other with Kafka. This means if a data center is down, not all data from the data center can be saved and replicated to the other data center. So you will have data loss in case of an outage. And this is for some use cases still okay, but for some other use cases you need zero data loss. You still can do zero data loss in such a way, but I will cover that later in this talk. But this is the big drawback in addition to the complexity like client failover and custom client coding, which you need to be aware of in this architecture. Many people, especially which just use open source like Mirror Maker, are not aware of this drawback that you will have data loss in case of disaster. One example where we do disaster recovery like this is JPMorgan, and we have tens of other customers doing this. But here is a great Kafka Summit talk where they explain in a lot of detail how they deploy this infrastructure with our help. And there is many things and best practices you have to think about, like not just switching to the other data center, but also then moving back to the first data center. And all of this with offset translation and no data loss or whatever your requirements are. So take a look at this talk if you want to learn how one of our customers does it. And this is really a traditional deployment infrastructure today at most of our banking customers, insurance customers, but also in many other industries. Another use case is aggregation of Kafka clusters. This means that you have often more smaller local Kafka clusters, like in different regions, and you have one big aggregation Kafka cluster somewhere in a data center or in a cloud, where you aggregate and consume the data from all the different data centers or edge local data centers. Because then you can combine and correlate the data, and that's often where you get much more value out of that, like for analytics, to find out why does something work well in region 1, but you have problems in region 2 with the same things. This also works and is relatively easy to set up. The same drawbacks like for the other replication tools we talked about with Mirror Maker and CONFLUENT Replicator. It's asynchronous replication, and it's also not the easiest way to do if you really want to have it in a mission critical way. But it works and is straightforward to set up if you have the right best practices and help for that. One example for this is Royal Caribbean. So what they are doing, they have the cruise ships where all the passengers are. And the cruise ships don't have very good internet connection. It's very expensive. So what they are doing, they provide a Kafka cluster on each boat, on each ship. And they do all the real-time analytics there, for example, for customer experience and cross-selling, all in real-time on the ship with location-based services and so on. And then when the ship gets back to the harbor, they replicate all the data to a central cloud cluster. And they do this for every ship, every time it gets to an harbor. And with this, then you have the aggregated cluster in the cloud, which is of course much, much bigger because there is the data from all the ships all over the time. And then they use other tools to analyze the data. And they use, for example, a lot of Kafka streams for do real-time stream processing with a Kafka native technology. Here again, it's a Kafka Summit talk. It's a great view to understand what they are doing. And also a little bit similar is aggregation of edge Kafka clusters. So remember the discussion where I talked about small deployments of a Kafka cluster, often with a single broker. And that's what we see a lot at the edge, which can mean something like retail stores of a shop, or it can be something like manufacturing, where you have small fabrics and factories somewhere. And in each one, it's not a real data center there, so you cannot deploy a whole infrastructure on Kubernetes or so. But therefore, you just deploy a single broker or maybe a small cluster with 3 brokers on very small hardware. So here you typically also don't have 128 gigabyte of RAM or so, but really more like 4 or 8 gigabyte RAM on small hardware. But you can still deploy the Kafka cluster there. We even see deployments where you, for example, work with an OEM vendor or hardware appliance so that you would just put it there and it runs continuously and you don't have to manage it at all, because at the edge often there is no administration and people which can handle it well. So you manage it from remote. And here it's the same then. You do your real-time analytics at the edge, but also replicate the data to a central Kafka cluster where you do the aggregation and further analytics and processing. In many cases today, actually, this is also bidirectional, which means that you do not just aggregate the data from the edge, but you also send data back, like commands or queries or some other rules, what you want to do at the edge. One great example here is Severstal. Severstal is a steel company in Russia, and they are reducing their downtime of their assembly lines by using Kafka and Kafka streams at the edge for real-time analytics with machine learning. So they deploy analytic models inside their Kafka applications at the edge to do real-time scoring and predictive maintenance and quality assurance within milliseconds at the edge. So this is something which you wouldn't deploy in a cloud, but really process the data where it is important and in motion. The last part here, it's also pretty interesting, and we see it more and more, is cross-company Kafka integration. In the meantime, everybody uses Kafka for event streaming, for messaging, large scale, for microservices. And then often, if you want to communicate with partners or with vendors or customers, you provide a REST API with HTTP. And that doesn't really make sense, right? It's not natural, and often it doesn't scale in the way you need. It's not real time, it's request response, and all these drawbacks. So streaming integration between companies totally makes sense if everything under the hood is streaming, right? And therefore, I think from a technical perspective, there is no question this is the way to go in the future. The biggest drawbacks we have seen here at customers is, of course, information security and politics. So there's a lot of discussions how to open the ports and firewalls and how to integrate with something which is not HTTP and web services. So this is where companies get better and better these days because the added value is so big. It makes so much sense to do API management and on a streaming way and not just with REST interfaces. And so why not simply directly connect Kafka clusters instead of putting an API gateway in the middle, which is an additional component? It doesn't scale well, it's not streaming. Well, I mean, I think you get the point. The real challenge here is internally in the organizations to solve the security requirements to do exactly this. Also regarding GDPR and legal data and all these kind of discussions you will have. So with that, let's now come to multi-region and global Kafka clusters. So this is the most interesting part, of course. So unfortunately, the bad news first. We talked about a stretch cluster before. A stretch cluster, remember, guarantees 0 data loss and 0 downtime of a Kafka cluster, even in case of disaster and the data center is down. However, this only works with good latency if the data centers are close to each other. So something like even here in one region, like in the US, you cannot deploy a Kafka cluster well over East, Central, and West. This works in theory, but in practice it's really hard, and especially in case of failure and problems, this is not doable, right? This is nothing which works well. So the workaround, which is typically recommended, at least until today, is that you replicate the data between different Kafka clusters. This is what we discussed before. You can use tools like MirrorMaker 2 or Replicator from CONFLUENT for this. And this actually even works between different regions or even continents like you see here. So this is pretty straightforward, and we see many customers doing this. However, the big point is this has the same challenges as we discussed before with Replicator. First of all, it's asynchronous replication for everything. Therefore, you cannot guarantee zero data loss. And also you have to handle all the other things like custom code for failover, the client side is changing and switching. You have things like offset translations. So a lot of things you have to handle under the hood. So it's not really easy to deploy this infrastructure for mission critical systems. For analytics, it's often fine because you can live with the drawbacks, but for zero data loss and zero downtime infrastructures, replication between Kafka clusters is not the right way, but often it's the only option you have. Having said this, there is one more option. You can deploy a single Kafka cluster over 3 regions with multi-region replication. So this picture looks like the picture before. So first of all, it's the same idea like a stretched cluster, but with additional tooling which allows you to get it running 24/7 without data loss. So what does this mean? So this means that CONFLUENT platform provides a feature which is called multi-region clusters. You can deploy a single Kafka cluster over different regions, similar like a stretch cluster, but with additional tooling so that it works. Here are the benefits of this. This guarantees high availability. So even if one region is down, the cluster continues to run, and it's one single cluster. So no additional overhead for you to develop and test. It supports automatic client failover over regions. It works well in cloud and on-prem or even in hybrid scenarios. You can guarantee zero data loss and zero downtime at the same point, like in a stretch cluster. And you don't need additional external tools like MirrorMaker because it just uses the Kafka protocol under the hood. The big drawback for some of you might be, it's not part of open source Apache Kafka, so you need to get the help of the vendor CONFLUENT who implements this innovative feature, and it's not an open source tool, it's a commercial tool. Of course, you could also build something by yourself like this, but that's really hard, and especially with the SLAs for mission critical systems, probably you don't want to spend this on your time on yourself, on the efforts, but buy it from the experts. How does it work? Under the hood, it has many amazing features built into the Kafka protocol, including region awareness, and you also can configure synchronous or asynchronous replication per topic. So this means that the most important critical topics are synchronous, like payments, fraud, whatever. This is often also not the biggest message size and throughput, right? These are very critical with zero data loss, and therefore you do synchronous replication between the different regions. And for not so important topics, often something like log information, here you configure them asynchronously. And therefore we solve this problem of a stretch cluster, that it also works over different regions, because not everything has to be done synchronously. And therefore it's also possible to do this without having to change the physics under the hood, which of course we cannot change. It has additional features like fetching from follower that you only consume from the local Kafka broker and not from the remote Kafka broker. This is huge because it reduces cost and latency a lot. We have regional topic locality and also different replication rules. So there's a lot of things under the hood. And this in the end helps you to build one single multi-region Kafka cluster for zero downtime and zero data loss. So here is how that looks like. Let's assume you have a single Kafka cluster here deployed. If the US West data center or cloud provider is down, and this happens, we see this all the time in the news, the clients can automatically fail over only to the other data center. So here you see on the US East, we already have the clients D, F, and G. But now also client A and B have to move from the failure side to the failover side, right? And all of this is happening under the hood, out of the box, without any testing or configuration or any other debugging by you and your team. And that's really huge for mission critical systems. Here is one example how you configure such a Kafka topic. As you see, use the same commands like before, like the Kafka Kafka topics.sh script to create a new Kafka topic. However, you have more configuration options like regional replication factor and region awareness. And as you see here, you can also configure the replication if it's asynchronous or synchronous per Kafka topic. And with this, you can configure your Kafka topics for the right SLAs for your use case. Pretty straightforward, like before. So our vision really is not just to have regional Kafka clusters, but really one global Kafka cluster. So let's talk about this maybe in 6 months or 12 months, then you will see what we have built here. But this is something which we are working on. Today, we already support regional Kafka clusters, which means we have battle tested our environment in US East, West, and Central. So this is really a very big Kafka cluster all over America. But in the future, it will get even bigger, where we can talk about a global Kafka cluster. One big thing of that is, of course, the Zookeeper removal. That's one of the main blockers today for Kafka scalability and elasticity. So this is where we are working on with the community a lot to remove Zookeeper in the next few releases, step by step. You can read the KIP 500 to understand this in more detail. But this is one of the core blockers today with Zookeeper, why Kafka is not available as a global Kafka, right? The logic of Zookeeper will be embedded into Kafka brokers, and with that, Kafka will get much more elastic and scalable. It does not just make operations much easier in the future, but also allows innovative new features like Global Kafka and these things. So there is no best solution. You have seen many different architectures for distributed, hybrid, edge, and global Kafka deployments. It depends on your use cases, requirements, SLAs. There is no best solution, as you can imagine. In best case, you get consulting from the beginning to understand what you have to do and what you can do in your architecture. With that, let's now quickly take a look at the infrastructure options. So there's many things you have to decide, right? Like, where do you want to run the Kafka clusters? Bare metal, in VMs, in containers, with Kubernetes or other cloud native tools, or directly in the cloud? Do you just want to use open source, Apache Kafka, and maybe some open source components from like CONFLUENT community, like the REST proxy or schema registry, or a commercial infrastructure where you have additional tools and support, or maybe a fully managed software as a service, where you don't host it at all, but just use it as a service? Do you want to self-manage it versus a platform as a service or fully managed? And then the other question, do you want to have it in a Kafka native way, or do you want to use different tools and combine them with Kafka? Like, do you use Kafka Streams as native stream processing engine where you have just Kafka running, or do you use additional tools like Spark Streaming or Flink or Storm? So it's no easy answer. There's always trade-offs. We are happy to discuss this with you for your business case and your SLAs. With that, just one word about what we do with CONFLUENT. So we provide CONFLUENT platform, and here the main thing is, as you see in the middle, everything we do is based on the top Apache Kafka open source project. We do 80% of the commits to Apache Kafka and do all the roadmap planning together with the community, and we are doing the release tests and integration tests. And therefore, we support Apache Kafka from day one when a new release is out, because we're doing most of the work there. But on top of that, we also have so many great tools. Some are open source, some are commercial, for development, for operations, for monitoring. And the big thing here really is it's also freedom of choice if you're on-prem, edge, hybrid, in the cloud, and if you're self-managed or if you want to use a fully managed service in the major cloud providers. This together with all the expertise we have. And I think you see it in this presentation. We see so many different deployments and architectures. This is our daily business, what we are doing with our customers. Therefore, one word I want to say about Kafka as a service. There's many services on the market in the meantime, from small and big companies. However, the big thing is that what most of these Kafka services provide is just the first thing which you see here in red, infrastructure as a service. This means that many services just allow you to provision Kafka brokers and Zookeepers. And then it's running, but you have to do all the other things under the hood, like the sizing, the performance tuning, the critical bug fixing, the scalability, the data balancing. All of these kind of things have to be managed by you then, as you see here. So this is not really good. So in the real world, a Kafka service should be serverless experience with consumption-based pricing where you pay as you go. But the point really here is about serverless, which means that you don't care about Kafka brokers and Zookeepers, about upgrades and sizing and performance tuning. You just say how much throughput you want per second in and out and pay as you go with an elastic scaling. And that's exactly what Confluent provides with Confluent Cloud on all major cloud providers in a highly available way with big critical SLAs, and of course with all the expertise and services and support we have. So that's a significant difference. Is your Kafka service really a fully managed service? Most on the market are not. I only know Confluent Cloud, which is really fully managed and serverless and consumption-based pricing with mission-critical SLAs for everything, including all the Kafka stuff. So having said all that, we see a trend that people are at different maturities with their deployments. This often starts with initial awareness where you try out Kafka, maybe on your laptop, maybe you set up your infrastructure, but then you grow as you go with the first use case, then you deploy it mission critical, often then also including a stretch cluster or hybrid or multi-region deployments over different clouds. And then you also start to begin really contextual event streaming apps. This means not just using Kafka as producer and consumer, but really leverage the client side. There's so many things you can do with Kafka on the client side to build your real-time applications, highly available, just with the Kafka infrastructure without anything else. And then obviously the final goal is the central nervous system with Global Kafka, where everything runs on Kafka. This is what many tech companies do today already, because it's highly available, it's scalable, it's real time, right? But this is a journey, and we typically see go step by step, otherwise you will be in trouble. And here we also, of course, help you with products, with support, with training, and with our partners. Last but not least, the point here about, again, end-to-end integration with 24/7 uptime and zero data loss. I have discussed a lot the different architectures and their trade-offs. However, the big thing you have to be aware of, Kafka is typically the central thing, and if it's down, you're in problems. And it's even harder for you the more different components you add. I often get asked questions, okay, so should we use Kafka streams, or what's better or worse than Flink or Spark streaming? And we also have this ETL tool and IBM MQ and ESB. So how can we combine them with Kafka? And you can do that. They're all complementary. There's nothing wrong against it. However, the big point is what you have to be aware of. The more components, clusters, technologies, this means the more risks, conflicts, incapabilities, and operations burden you will have. And therefore, for end-to-end mission-critical integration and streaming, right, the more different products and infrastructure to use, the harder it gets. It's that easy. And therefore, you should always ask the question for yourself, if I have Kafka anyway, and even if you just use it for messaging in the beginning, why should I use an additional component to make it harder to get the end-to-end integration possible without data loss and without downtime? And in this case, you always should evaluate, like you see on the right side, maybe with just Kafka, there's just one infrastructure to run end-to-end 24/7. Sometimes you still need something else. It's totally fine and complementary. And all of the other tools has also connectors to Kafka, so it's all complementary and totally fine to use existing tools in your infrastructure. But for new projects, you should really think about, do I need the other stuff, or is Kafka good enough? With that, I'm finished here. I hope this was a good overview about different kinds of Kafka architectures over different data centers, multi-cloud, hybrid, deployment at the edge. We see all of this at many different customers. So please let me know what you think. Connect to me on LinkedIn or on Twitter, and let's see what kind of Kafka deployments you have in your architecture.